We were talking about the CPU, the central processing unit. The last thing I believe we discussed was the processor celerity or the processor speed. We presented and we said that the actually architectures of processors, commercialized actually processors, we talk, they are up to date, described to be a multi-core processors. We may see actually up to 12 core, 16 cores, sorry, 16 cores, commercialized models or architectures, utilized for service, mainly dedicated applications, dedicated computers. Other than that, actually, the very famous desktop computers, or let's say laptops, they are actually based on 6 or 8 cores. Those are commercialized. Those are commercialized. Means commercialized means they are actually, you can go to the shop and you buy them. You'll find it's very easy to do, and they are actually handy in terms of cost. Means you can buy them, you can afford them. It's not, they are not expensive enough to block you, to forbidden you to that you cannot buy. No, no, no. You'll be able, even if they are a little bit, maybe you find, for example, when we talk about the 16 core CPU based computers, you may buy them, but it's a little bit costly. But you can, as a personal, as a person for a personal use, you can at the level you can reach to buy them, because we may find dedicated computers with dedicated CPUs that they have up to 3,000 cores. See the number? I said 3,000 cores. Those are actually processors that they do actually the machine learning and the artificial intelligence and the actually yes, the artificial intelligence tasks in a graphical way, and they are a very dedicated computers, and they're very dedicated processors to do very tiny and very sensitive computations. Thus, they are in need of such a huge number of cores to do the computations in parallel. uh, they are not for commercial use. They are not for use at home. They are not for use for a desk activity, or let's say educational activity. They are for dedicated activity, but they are available. I repeat, we may reach to find up to 3,000 core-based CPUs, but they are not for commercial activities. They are not for to find them in the market. They are not things that you go to the shop and you find them. No, you may ask them to be manufactured for your business, specifically if you need them in cases. But they are available. At the end of the day, multi-core based CPUs, sort of sort of dedicated processors. They are given a chance to be more fast than the antecedent CPUs. They do computations in parallel. When we say core, means actually it's a layer. See, this is actually a CPU. Inside of it, we'll find cores. Actually, what does it mean? It's a layer, as if we are saying a CPU, this box, on top of another, or on top of another. So if we say, for example, 6 cores, as if we are saying 6 CPU, 6 blocks like this on top of each other. But they are all inside this small box. See, inside of this small box, all of them, the 6 core or the 16 core or the 10 core, they are all inside here. They are layers on top of each other, like it is, to do the computations um, in parallel, no more, no less. Manufacturers actually, they are a question of property. When you talk about the architecture, how the architecture is set, the Intel here is one manufacturer, the RAM he actually is another manufacturer. Manufacturers, they are proprietarians of the architectures. Uh, those actually celerities and this speed that we talk here, that the multi-core processors, since we have to say that the multi-core processors, they are much more faster than the normal and the antecedent processors. Yet, yes, so there is a measurement, there is a unit that we can utilize to measure. I'll come back to this slide. There is a measurement via which we measure the speed. When we say that the processor is fast, what does it mean? So there is a unit that we have to utilize to measure this speed. Those units, they are things we explain just in a way. I was saying that the 3,000 that there are actually available in the market, actually 3,000 based core multi processors, and they are actually working on the graphics. Mainly, they are dedicated CPUs that they do the artificial intelligence tasks, something like that, and they deal with the graphical, also the graphical activities. The gaming computers. When we talk, I give you another example. The gaming computers. When you go to the shop and you find a computer and they tell you that this is a gaming computer. What does it mean, a gaming computer? This is actually a computer that has a potential to do a faster process and a faster computation when it deals with the graphics, because a 3D, let's say, graph is not the same as you are just displaying a simple 2D graph, a picture or image. So there are potentials, there are capabilities required that the processor has to fulfill in order to finalize the process. Thus, there are sorts of dedicated CPUs for graphical activities. When we say CPU, central processing unit, as if we are saying also here the GPU, as if we are saying CPU simply, but it deals with high resolution based graphs. It deals with a very, let's say, heavy graphs, medias. The example, the games mainly. Great. Can be located. Actually, yes, it is at the end of the day, it's actually a processing unit, the GPU, graphics um, processing unit. Yeah. Uh, the role of those GPUs actually too, as I was saying, as I was describing the game computers, for example, as per title of example, they are models, but they are built on top of a GPU, not a CPU. They are 100% capable of rendering, I repeat, the 3D, let's say, outcome into a visual, let's say, media. Because the computer, remember, the computer does not recognize what is an image, does not recognize what is a voice, does not recognize what is a video. He recognizes a file with its specificities, and we presented that. The same way, when you talk about a media that is 3D, what does it mean for the computer? Also nothing. For the computer does not recognize what is 3D or 4D or ND. He does not recognize that, but he knows a file with its specificities. So a normal computer based on a CPU or a basic CPU, a very, let's say, habitual CPU, ordinary CPU, you will not be able to process this 3D, let's say, content or media as when we talk about the GPU. Why? Because there are heavy potential required to finalize the processing of the media to give us the final view. The normal CPU is slow. It cannot finalize the processing capabilities on time because the 3D, it has to be actually processed in real time. When we open a 3D, let's say, game or 3D video, 3D, let's say, a media, it has to be processed and immediately displayed. This immediate processing of 3D media, it needs potential, it needs more actually capabilities. The CPU will fail to do so. In so many cases, it will struggle, it will stuck, it will not do the thing in real time. It will process portions and it will stuck and so on. The GPUs, they are to solve such a matter, and they are actually to finalize the display in real time. However, the specificities, those are titles of examples only. The size and the dimensions we are seeing in output, because you may find a variety of 2,000 foot long actually track. It is an example only to present the power that the GPU can present. 2,000 foot long track, actually it has to be manifested in 3D environment. It is not something easy that a normal computer will do, but the GPU can reach to do. It's an enormous capability of computing, enormous capability of computing. From other activities that the GPU can do, actually, it's synchronize the actions. Remember that 3D, it's a media that can be a video, can be a game. So there are sequences of frames to be displayed. The synchronization of those sequences, the GPU can synchronize easily when we compare it with the CPU. Does not mean that خلاص it will do. It's easy. GPU, so he will do. No. But when we compare the GPU to the CPU, it is an easy task, the synchronization. The GPUs also, they are capable to treat 4K resolution based graphs. What does mean 4K? Means you are just given this resolution to the computer, 4 by 1024 by 1000. Just let me uh, eliminate this graph. See the number here. See the number here. 4K means by 1024 actually height and width. This number here actually is the resolution of a graph. Let's say something like let's make it easy. We said that 1K. We said 1K at that time when we presented the units. It is 1000 1024. But let's take it as 1000. Sorry, to make it simple for you because you are not related to the computer field. Let's say 1000. So 4K. When we say 4K, it's 4 by 1000 by 1000. The resolution 1000 by 1000 height and width, and multiplied by 4 means we are having a very deep resolution. It's very neat, very clear, very, let's say, perfectly viewed, the content. Multiplied by 4 even. It's not still, this resolution is very high, and we multiply it by 4. It's a normal computer, a normal CPU will fail in processing such resolution. In so many cases, you will not be able uh, to visualize it perfectly. At least you will not be able to synchronize the frames if they are a sequence of frames. So the GPU has to do this role. This GPU has to do this role. Good. Real time, yeah. Everything is in real time only. So when we say real time, it does not mean that there is a video to be broadcasted, but the synchronization has to be immediate. Once the broadcast starts, the display has to happen. There is no delay, there is no latency, there is no difference in time. We submit now, we broadcast now. After 1 second, after 1 second or 2 seconds, or after a period of time, the display will start. No, it's an immediate action. It's an immediate action. Remember that the 3D, if it's an effect, it's a virtual environment. It's not real. We cannot talk about real time as if we are diffusing now. No. It's a broadcasting, but the broadcast has to happen immediately. Once we ask the processor to execute, it will do immediately. So it's a real time. Thus, we say it's a real time. Units via which we measure the speed, whether it is a CPU or a GPU, there is a speed unit. We have two groups of measurements here. Either we talk about the hertz as a basis, means a hertz is a unit, 1 hertz, 2 hertz, 3 hertz, 1 kilohertz, 1 megahertz, 1 gigahertz, 1 terahertz. Those are units via which we measure. 1 hertz means actually it's a number of x instructions per second. 1 hertz is x instructions per second. What does mean x instructions per second? Means actually it's the proportion of the time, no more no less. So either we say that we are having a CPU that have a speed of let's say 2 megahertz or 2 gigahertz or 3 gigahertz or something like that. So the hertz here, in order to avoid the technical description, is the reciprocal of the time. It's the proportion of the time. Means actually 1 hertz is as many instructions, let's say, divided by time. Instructions divided by time. The hertz is the number of instructions divided by time. All of this is described in our book. So 1 hertz is, let's say, 1 instruction per time, which is a second, something like this. Regardless, why we measure the hertz, it's not a radio here. It's not a radio. We know actually the radio broadcasting, your car, it receives actually the radio because of the hertz frequency, something like that. It's not this. We are not talking about radio broadcasting. We are talking about frequency of calculation. The frequency of calculation. How many instructions it might calculate per time, a frame of time. The frame of time might be actually a second, might be a minute, might be an hour. We have a gap, but mainly by default we talk about seconds. And this measurement, whether this measurement or the other one, we'll talk about it just in a while. We are having a tool to measure. Who is saying that this CPU is doing actually the calculation of 1000 megahertz per second, means 1 gigahertz per second. So the speed of the CPU is 1 gigahertz. The speed of the CPU is 1 gigahertz. Who said that? Actually, there is a tool to measure. There is a tool to measure. Every each single computer, whether it is a laptop, whether it is a desktop or server or mobile device, even they are equipped. They are equipped in their motherboard with a clock. A clock. Yes, it counts the time, and this clock measures the speed that the processor is following. It means the number of instructions that the processor do within a period of time. The second way how we measure the speed is using actually the number of instructions per second. Number of instructions per second. We say that the processor can do million instructions per second, megaflops. We say that the processor, the CPU, can do billion of instructions per second, so gigaflops, or whatever. X instructions per second. This is another unit. It's actually another tool that we can utilize to measure the speed of the CPUs in general. Usually, actually, we can do actually a test to check up if the speed is expected or not, or whatever the number is given actually is fulfilled and the CPU is reaching that level or that speed or not. We talk about benchmarking. Any questions here, please? No questions. We continue. The CPU, still we talk about the CPUs only. They have an architecture, as we talked about the multi-core, as we talked about the multi-core processors, and the concept of this multi-core is it's an architectural design via which the processors they are able to do multi or parallel computations at the same time. Also, in the architecture only, processors they are able to receive more than 1 bit per second. They are designed to actually to receive in parallel a flow of data per each input. I repeat, the processors, the CPUs, they are designed to receive a flow of data per input. At each input, there is a flow of data. It's not 1 bit. We said that the data represented to a processor, it is a binary data, either zeros or ones, either a pulse or no. It's either an electrical pulse to be submitted or not. This is the data to be, this is the representation of the data to the processor. Still in this same context only, each processor either to receive 32 bits per input or 64 bits per input. Either this or that. Those are the commercialized, actually, those are the architectures that the processors follow to finalize their processor. Actually, they are not receiving bit by bit. They are receiving either 32 bits per input, and they do their process, and they receive the second flow, which is the 32 bits, and another, and another, and another. Or they receive 64 bits per input. They start doing the process, and they receive a second 64 bit, and the third 64 bit, and the fourth, and so on, endlessly, and until the data has been, the inputs has been finalized, terminated. So this is another architecture that pushes the processors to be much more fast, and it is a context of computation capability. This is said a word size. This is nominated a word size. The word size that actually a processor can receive can be mainly made up of 32 bits or 64 bits. The size is either 32 bits or 64 bits. Also still in the context of architecture only, and to make the processor much more fast and to make the computer in general much more fast, the use of memories. There are models of memories that they are utilized only for helping the CPUs to finalize the process and the computation in a fast time, in a very short period of time, let's say faster, nominated cache memories. Those cache memories, they are to be utilized by the processor to hold data locally for a short period of time. I repeat, those cache memories, they are to be utilized by the CPUs to hold data locally and for a short period of time, not for usual. No, just for a short period of time, during a second, during 2 seconds, during 1 hour, a given time, and then after it will be released. What does it mean? Emptied. Everything will be deleted automatically. The user will not interfere here. It's the role of the CPU to utilize this cache memory or those cache memories either to store or to retrieve data from or to delete them, the data from inside. So it is not the user who will do. It's not me or you. It is the computer to do that. It is an autonomous behavior using the cache memories, whether to store or to retrieve or to empty them. Empty means to delete everything from inside. There are levels. There are three actually. Mainly we talk up to date. There are three commercialized cache memories. Computers, commercialized computers. They are equipped with three levels of cache memories. We say levels because they are segregated in three different places. One level one, or the model number one, actually it is the cache that it is available in between the RAM memory and the CPU, just right before the CPU. And the others, level 2 and level 3, they are internally built inside the CPU. In general, we say that the cache memory it is stored and it's built in the CPU because they are to be utilized by the CPU only. They are not to be utilized by something else. They are to be utilized by the CPU only. Whether it is level 1, just right before the CPU, or they are built inside level 2 and level 3 inside the CPU. All of them, we say in general that they are built into the CPU. Why? Because all of them they are to be utilized by the CPU only. Nobody will utilize those cache memories but the CPU, not the applications, not the operating system, but the CPU to utilize them. What? Why? To make actually faster processes. Any questions? No questions. I was discussing actually the memory, the RAM memory. Why did not ask? Are you with me? We come to it and we'll define just in a while. Let's continue. Let's continue. Just still talking about the computation CPUs, but we define something new. The bus uh, peripherals. Actually, when we talk about the bus, we talk about data transmission. When we talk about the bus, we are going to talk about the data transmission. Uh, when we talk, when we define the word size, who is going to deliver 32 bit per second or per input, or who is going to deliver 64 bits per input? The normal electrical wires? I don't believe so. I'm going to show you sort of cables, electrical cables. You see the graph now? Are you able to see the photo I'm showing you now, or the images I'm showing you now? Is it visible to you, please? Khalif, are you with me? Okay, okay. Such a wire, so actually a group of wires, If we utilize, for example, this black or this white or this violet or this gray, whatever, one of them, we utilize them to connect or to send data to the processor, and we receive the input or we get the output. Is any of those wires here is capable of transmitting 32 bits per second per input? No, no. Each of them can transmit in serial, 32 or 64 or more, but not in parallel. So we utilize all of them. Those are not for data. Those wires, they are not for data. Those wires, they are for only for current, to pass the current, the electricity only. But bus data, they are capable to transmit bus data. Give you the example. This is the bus data. Those wires here, they are capable of transmitting 32 bits per input or receiving 32 bits per output, or the 64 they are able to input 64 bits per input مع بعض. They are in parallel, all of them in parallel, just in one slot. They input 32 bits or 64 bits, and they take in output 32 bits or 64 bits at the same point, at the same shot. So those are kinds of bus wires. And those actually, they are mainly an electronic path to transmit the data, or to help to the data to be transmitted either to CPU or from the CPU. They are linked to the motherboard mainly, absolutely, and they link peripherals to each other. They link peripherals to each other. The whatever, the, let's say, the CD drive to the motherboard, floppy to the motherboard, um, whatever they are, to interrelate the peripherals to each other inside the case, and we define what is the case. Whenever the bus is more wide, we talk about much more data to be transmitted at the same time, at one time, at the same time, means in parallel. Everything is in parallel. A view of the bus data, a view of the data buses. This is a small one. It transmits 8 bits only per input or per output. This is a little bit more wider, 16 bits per input or per output. Whenever the bus is wider, the data to be transmitted at the same time actually would be actually much more bigger. Means if we have actually a bus data of 32 bits or 64 bits, we can transmit much more data per input. Thus, we can finish the process much more faster. But if we use an 8-bit bus, we have to transmit the thing 8 bits per input, 8 bits, then 8 bits, then 8 bits. It is much more, actually, it will consume much more inputs than much more time. So it's much more slower. Memories. We were talking about, actually, I discussed now only, we were discussing about the cache, and I asked you about the RAM. The memories, they are actually sort of storage devices. They are hardware responsible for storing the data with different sorts. When we talk about the different sorts, as per actually the ship memory, the ship memory we defined just earlier, the cache memory, sorry, the cache memory we defined just earlier, it is to be utilized by the CPU, and there is no interference from the user, from the end user. Why? Because they are having a specific role to help the processor do much more computations with less time. That's it. They are not to be utilized by you as a user to store data. So this is a memory that has a specific purpose. Whatever the purpose is, they are all storage devices. They are all storage devices. A memory is mainly, it's a microchip. It is something to be actually something like those. I'm going to show you something like those microchips here. This one, maybe something like this one. Microchip, they are similar, whatever, they are similar to those things here. Whatever. So they are microchip. They are done in silicon or something like that to facilitate the storage of enormous data in a very small area. From the characteristics of a storage memory that has to store for a long time. What does it mean? If I store my data now and I go home and I use it after 1 week or after 1 hour or after 1 day or after 1 year, it has to be available. Otherwise, the memory is not working fine. So it has to give this potential. The memory has to store the data for long term. It has to store the data for long term. There are types. There are types. From the type that do not have this property here, the RAM, the random access memory, which are to be utilized by any live program in the computer. Means to open this slide, it has to be displayed from a memory. The memory responsible for running application is the RAM, the random access memory. It is to be utilized for live executions only. Means everything to be run on the computer, it has to be put inside the RAM, then displayed to us in the screen. The RAM is the place where to put the run applications or the run processes in the computer. So the processor will display the RAM, will put the slides, for example, if we talk those PowerPoints, inside the memory, then display them to us in the screen. So the RAM, the random access memory, those are nominated random access memory عشوائي, دخول عشوائي. Why? Because actually to be utilized by every and each single run application at runtime only. If we close the computer, everything will be actually deleted and the RAM will be emptied. Here, if we close the computer, I said, not like the cache memory. It will be storing the data for a period of time and then automatically will be deleted. No, here only if we close the computer or if we close the application. But if the application is open, it will not be deleted from the RAM unless we can close the computer or we close the application itself. Chips only. It will be connected to the motherboard and it holds everything to be run in lifetime. Currently means immediately. Whatever you open, it has to be available in the RAM only. This is a graph. This is an image representing. Those are two models. This is actually for a desk computer, and this is for a laptop because of the size only. We have two portions. Actually, see the yellow, the silver here. It is the place from where to connect this RAM to the motherboard. This is the silver is the place from where to connect this RAM to the motherboard. Those chips here, they are the place where the data are stored. Those chips, the black boxes, those are the place where the data is stored. The properties of the RAM, it is volatile, means once you close the computer, everything will be deleted. If we close the computer, whatever the programs you run, the RAM will be emptied. But there is another type of memory, which is the ROM, read-only memory. Read-only memory. This is another sort of memory to hold how the system actually specificities. We say actually two operating systems respond to. Let's say there is a system responsible for the input-output and how to run the operating system, when to load it, the boot, where those actually executions and tasks and commands they are stored. They are stored in a ROM. They are chips. They are also chips available in the motherboard to store such instructions to be executed by the computer only. You cannot modify them. Mainly, we can nowadays we can do, but as per the theory, we say that the read-only memory, it holds instructions to be utilized by the computer only. You cannot modify, you as user, and you do not have the right to modify because those are the instructions how the computer would run. They are non-volatile. those sorts of memories, they are not volatile. What does it mean? It means if you shut down the computer, they're not like the RAM will be emptied. No, no, no. Everything will remain there. They will not be deleted. The content will not be deleted. The measurements, whatever we talk about the RAM or the ROM, they are in bytes only. There is actually one very context of being famous, being famous, more or less. Volatile memories is the SDRAM, is the synchronous or dynamic, synchronous dynamic RAM. Those are types of how the fact of being random being executed means it's a sort of how the RAM act. Synchronously actually means it will be updating the content block by block. It inserts one portion and it will it will pass, it will read the second portion, and then after the third portion, and then after the fourth portion, and so on. The same way when to send the output, it will execute, it will send the output the first portion, then after the second portion, synchronously. Whatever. Those are models. Actually, they describe the RAM, how they are the RAM. When we talk about the RAM in plural, how they are either storing or how they are sending out the data. Okay, I'll stop at this level. Still, the memories only. I'll stop at this level. I'll call you by name, please, if you are here. The midterm, actually, it would be on your on next Tuesday, 28th.